Okay, students, welcome to AP Bio Diffusion Lab 1A. We're going to go ahead and get started today. Let me show you some of the pieces of equipment you're going to be getting. This is your nifty, ever-present supply box with all your goodies. So your regular test tube and test tube rack. You have in here, these are the diffusion tubes that you'll be using for Lab 1A. And this is your pipette that you'll be using to transfer the sodium chloride solutions. Here is a pipetter. It's a mechanical pipetter, so you just work it by rolling this up and down, and that either aspirates up the solution or dispenses the solution. You have your nifty glass rod, 400 milliliter beaker. Also, some of the stock solutions in class will be dental floss, well, not stock solution, but stock item, so that'll be at the front of the room. And you should also have in your kit a conductivity probe for Lab 1A. Okay, so let's go ahead and get started. Of course, you have your notebook all ready to go. And, oh, I forgot to mention that you also have your lab quest. And your lab quest should be in a storage box. Go ahead and take it out and then get ready to go, because this is the first thing you'll set up. So if I'm looking at my instructions, the first set of instructions say that you should set up the utility clamp, which is what this is. Okay. So there's the utility clamp. Hopefully you can see it fairly clearly. We're going to go ahead and set up the actual conductivity probe, so you need to take that out of your box. So box, conductivity probe, go ahead and take that out. It comes falling out. Okay. It's pretty durable, so it'll survive minor falls. It says to select the probe switch to 0 to 2000 microsiemens per centimeter. And so if you look closely, that one is set at 2000. Okay, so that's what you need to set it at. If your particular unit doesn't have that, then see me and I'll see what particular range it's reading in. Okay, so the next thing you're going to do is go ahead and take your lab quest like this. Go ahead and turn that on by pressing this button up here. It should take a second to turn on. Let's take a peek at that. Yep, it's all on. Then you take the male adapter end of your conductivity probe, which is what this end is, and go ahead and insert it into channel 1, which is on the back there. Go ahead and insert it like that until it clicks in. And then if you look at the screen again, the meter screen actually picks up the fact that this is a conductivity probe. If for some reason you do not see that it says conductivity, then see me right away and we'll get you set up. Okay. The next thing it wants you to do is actually to change the reading selection to a rate of 0.2 samples per second. Okay. I'm not going to actually show you that because I want you to figure it out yourself. But basically you can take the stylus, and when you tap into this section here that says rate, then you'll be able to see the different variables you can select. So when you're done, it should say 0.2 samples per second. And this one actually says 1 sample per second. So yes, I would need to actually change that. So I'm going to go ahead and change it myself, and then you should do the same on yours when you get yours as well. Okay, so if you look at my lab quest now, you'll see, maybe, I hope, that it says 0.2 samples per second. Okay, it didn't take too long to change that, but you definitely need to get it changed. Okay, so I'm going to go ahead and show you the basic setup. Basically, you take your conductivity probe and just run the wire right through the holder. Because the holder isn't big enough or small enough to actually hold the probe, then you can just let it dangle like that. This is just going to hang to the side here like this. And you're ready to go. Okay. That's the basic setup, but of course you'll have a beaker full of what is called DI water. Go ahead and pop that in there. Okay. And when you're actually going to carry out the test, then you're going to need to drop this into the water so it's submerged. It does not need to be directly in the center because through diffusion the salt will actually move around. So you can see there the probe is definitely below the level of the water, and I'm ready for my dialysis bag. Okay, at the front of the classroom you will have a beaker full of dialysis tubing, so go ahead and just get one out. You don't want to handle the actual tubing too much because there are microscopic holes there, and if you handle it with your hands, then you'll basically block the holes with your oils from your skin. In order to open up the tubing, you generally use a little friction back and forth, and that should get the two sides to actually peel apart. Okay, it took a little bit of just kind of teasing that end open, but the dialysis tube is now open, and in order to inflate it you could just blow into it, and then that will actually kind of form a nice tube there. So if I blow into it, it'll look like this. And so now the dialysis tube is somewhat ready to go. So now I'm going to tie this one end off with dental floss. Get your dental floss, little section. It helps if you have two people to do this. It says to tie it off at about 1 centimeter. So that's about 1 centimeter from the bottom. So I'm going to use dental floss to tie a nice strong knot. And do a second one just in case. Okay, so that one looks pretty good. And now I'm ready to actually add sodium chloride to my dialysis tubing. At the front of the class will be solutions of 1, 5, and 10% sodium chloride, so you need to go to the front and basically fill up your test tube with about 15 milliliters of sodium chloride. The way you do that is that you can take your pipette, pop it open just by basically unpeeling it like this, take that out like that. You can use this in order to attach it to the end, nice and firm like that. And then when you roll this back and forth, it will actually aspirate out the sodium chloride. Okay, so this is my test tube of 1% sodium chloride. So I'm basically going to go ahead and put the pipette in and then use my thumb to actually start aspirating. And as I do that, you can see the volume is going up in the pipette until it hits to 10. Okay, so it's at 10 mils of sodium chloride. I'm going to take my dialysis tube here and basically insert the pipette tip into the tube and dispense 10 mils. Okay, now I'm going to tie the opposite end off with another segment of dental floss. And it says to try and tie it next to the volume of the sodium chloride so there's not a lot of air in there. So I'm going to just kind of squeeze this closed a little bit best I can. You don't want to tie it way up here. You want to tie it down towards the liquid level. Again, it helps if you have two people to do this. One person can be holding, the other person can be tying. So, okay. So there you go. That's my upper knot. So now this is a closed system here. So I'm going to go ahead and tie a second knot just in case. Now I'm going to cut off the excess dental floss and dialysis tubing. So we don't need all that, so I'm going to just take my scissors, snip it off. Don't want the dental floss to get in the way. Dental floss is gone. Next thing you need to do is run this under some tap water, because if you have sodium chloride on the outside of the bag, you need to remove it. So I'm going to go ahead and do that. Okay, here's my volume of 300 mils of distilled water, and as long as I use this beaker for the remaining tests, then it's okay to use the graduations on the side of the beaker as long as it's constant. So I'm going to go ahead and set it up on the vernier. And drop that down, drop the probe down, let it dangle a little bit. And now I'm ready to go ahead and make sure my LabQuest is ready. Can be a lot of lines, so just be careful with where your equipment is. Make sure your LabQuest doesn't get wet. Okay, there's a reading in there already, but as long as it's steady, then I'm ready to go, okay? Because it's just going to take the rate from where you are, so it does not need to be at 0. Okay, so let's go ahead and get it going. Take your dialysis bag, which is closed and it's been rinsed with DI water, and drop it into the beaker. I'll take my glass rod and go ahead and stir it gently. Do this for about 15 seconds. At which time now I'm going to go ahead and hit the start button. So the start button on the LabQuest is either the green button right there or this button right here. So I'm just going to press this button. And it should change to an actual graph, so you can see your data come off on the graph immediately, which is pretty nice. So you keep stirring as you go along. So at the end of 60 seconds, the scale of the graph actually resizes itself. So you might look at that and go, wow, that's a really big slope, but actually it may not be as big as when you do the higher percentages of glucose, or it may not be as high as when you do the higher percentages of sodium chloride. Okay, so it just rescales itself based on the data it currently has. The next step is to follow the instructions on the handout in terms of how to actually find the slope of your line by doing a curve fit and a linear fit equation. So once you do that, then you'll be able to get your slope of your line. One thing that it does say is to save your run. So in order to save your run, you need to click that file box there. So I clicked it and it changed to run 2, so I'm now ready to go ahead and start collecting data for my second run, which is the 5% sodium chloride. When you're eventually done, you're going to want to save your data, so the best thing to do is just hit File, Save. You can use the keyboard to type in a title. So you should do like maybe period and your last name and the name of the particular lab. And then also I require that you save this to a thumb drive or a memory stick, because this data will get wiped out occasionally, and if you're expecting that next week you can go back and retrieve your data, that may not be the case. So always save your data to a thumb drive so that you can analyze it, because you can take the data from this LabQuest and actually analyze it at home using the same software on here at home.